Our solar system, it's home, right?
Hmm.
It's familiar. But it's also just this tiny little speck in this huge cosmic ocean. What's out there? Beyond, the usual planets and the sun. What mysteries and wonders are hiding out there in the darkness? Welcome to Cosmos in a Pod Space and Astronomy series. Today we're taking a deep dive into the universe outside our solar system. And you've sent us some amazing stuff, so let's explore it together.
You know, it's amazing. Even the space just outside our solar system, the space we think of as empty, well, it's actually buzzing with activity.
Oh, okay. So it's not just like completely isolated out there then. What kind of buzz are we talking about here?
Well, within just 15 light years, which is actually pretty close when you think about space, there are about 50 star systems.
50. Whoa. That's a lot more neighbors than I would have thought.
hmm
So what are these star systems like? I mean, are they kind of similar to ours, or are we talking about something completely different?
Oh, there's a huge variety. Some are just single stars, like our sun, but others are binary systems with two stars orbiting each other. There's even some with multiple stars. And a lot of these systems, they have their own planets, just like ours. Some even have these things called protoplanetary disks.
Okay, hold on. You lost me with protoplanetary disks. What are those?
Well, picture this. It's this swirling cloud of gas and dust, kind of like a cosmic pancake. And in these disks, that's where brand new planets are actually forming. It's like watching a solar system be born.
Wow. That's amazing. So new worlds are coming into existence right now, like just a cosmic stone's throw away. So are there any of these star systems that are particularly interesting in this neighborhood?
Oh, tons. Let's start with one that's actually headed our way. It's called Barnard star. It's a red dwarf just 6 light years away. And get this, it's zooming towards us at over 100 kilometers per second.
Hold on. It's coming towards us. Should we be worried about that?
No, no, not at all. It'll become our closest stellar neighbor, but not for about 10,000 years. And, well, 10,000 years might sound soon, but that's like forever in space terms. What makes Barnard star so interesting, though, is that it has a planet, GJ699b. It's a super-Earth. So that means it's much bigger and heavier than our Earth.
Super. That sounds impressive. But is it anything like our planet? Could there be, life there?
Well, that's where things get really interesting. GJ699b is a lot colder than Earth. Like the surface temperature is around -168 Celsius. That's way colder than Antarctica. But there's a chance it might have a subsurface ocean heated by tidal forces from its star.
Whoa. A hidden ocean under a frozen surface. Now that's cool. Imagine like life huddled around these geothermal vents in this secret ocean completely alien to us.
Exactly. It's a place scientists are definitely keeping an eye on. But let's move on to a star you can actually see in the night sky. Have you heard of Sirius, the dog star?
Oh, yeah. Sirius, it's always the brightest one. What's the deal with that one?
Sirius is kind of famous in the night sky. It's actually a binary system, meaning it's two stars orbiting each other. About 8.6 light years away, Sirius A is the one we see shining so bright. It's a blue-white giant, twice the mass of our sun and 25 times brighter. But its partner, Sirius B, is something else. It's what we call a white dwarf.
Okay, wait a minute. What exactly is a white dwarf?
Think of it like the dying embers of a star that's used up all its fuel. Super dense and faint, just this little glowing leftover piece of what was once a huge star. The process of Sirius B becoming a white dwarf was probably pretty wild, and it might have actually stopped any planets from forming around it.
So any planets around Sirius B would have been destroyed during its transformation? That's pretty dramatic.
It is. Really shows the crazy power and chaos that can happen out there in the universe. But speaking of solar systems, how about one with not one, not two, but three rocky planets?
3, now you're talking. Tell me more about this system.
It's called Wolf 1061. It's a red dwarf system about 14 light years away. And each of these three planets has its own unique story.
Okay, I'm hooked. What are these planets like?
All right, so the innermost planet, Wolf 1061b, is tidally locked to its star.
Tidally log meaning.
It means the same side of the planet always faces the star. Kind of like how we only ever see one side of the moon, so one side's constantly baking under the star's heat, making it super hot, probably not a good place to live. Then there's Wolf 1061, the farthest one out. It's bigger and much colder, probably an ice giant.
So we got a burning world and a frozen world. What about the one in the middle?
Ah, that's Wolf 1061c, and this one's really interesting. It's a super-Earth, like the one around Barnard's star, and it sits right in the habitable zone.
Habitable zone, so it could have liquid water, maybe even life.
It's possible. Wolf 1061c is a prime target for scientists looking for signs of life beyond Earth.
Wow. 3 completely different planets, all orbiting the same star. Makes you wonder how many different kinds of planetary systems are out there.
For sure, it shows the huge variety of worlds out there, each with its own unique story. But let's switch gears for a second and talk about a planet that might be even more Earth-like. It's called Gliese 370b.
Okay, Gliese 370b, another super-Earth in the habitable zone.
Yeah, but this one's just a little bit bigger than Earth and might have an average temperature around 25 degrees Celsius. Think a nice spring day all year round.
Sounds pretty nice. A temperate world orbiting another star. I mean, it blows my mind to think about what that place might look like. Could there be oceans, mountains, forests?
It's amazing to think about, right? Okay, now get ready for this. Imagine a sky with not one sun, but six.
Wait, 6 suns? Are you serious? How does that even work?
It's this complicated dance of gravity and orbits. The system's called Castor, about 50 light years away. It's got 2 pairs of binary stars orbiting each other, and then another, farther out, pair of red dwarfs circling the whole thing.
Whoa, my brain is trying to picture that.
Yeah.
A sky with 6 suns, it'd be like constant daylight. What about gravity? Wouldn't a planet in that system get pulled in 6 different directions?
Well, no planets have been found in Castor yet, but it makes you wonder, right? What would it be like to experience a day, or I guess no day at all, on a planet with 6 suns rising and setting all the time? It would be like nothing we can imagine.
It really puts our own little solar system in perspective. But all these systems we've talked about, they're still pretty close to us, right? Like in the grand scheme of the universe.
That's right. We've been looking at our little corner of the galaxy, but to really get the big picture, we got to zoom out and look at the bigger structures our solar system's part of.
Okay, let's zoom out then. What's this grand stage our solar system is on?
Well, right now we're moving through what astronomers call the local bubble.
The local bubble. Sounds kind of fragile. What's that exactly?
It's this region of space filled with super thin, scorching hot gas, so spread out that you wouldn't even feel it. Think of it like a giant bubble created by old supernova explosions.
So we're just sailing through a giant bubble of leftover supernova stuff. That's wild. What happens when we leave this bubble?
Well, in about 2,000 years, our solar system will enter a different region called the G-cloud, another area full of this gas called ionized hydrogen.
So it seems like our solar system is constantly moving through all these different environments.
Yeah,
Really shows how dynamic and how much a galaxy is changing all the time.
exactly. And speaking of the Milky Way, let's talk about our galactic home for a minute. It's a huge spiral galaxy with over 200 billion stars and probably over 1 trillion planets.
1 trillion planets. That's insane. So where do we fit in all of that?
Well, we're located in one of the Milky Way's spiral arms, called the Orion Arm, but the whole galaxy is filled with amazing structures.
Like what? Give me the galactic highlights.
Well, there's Barnard's Loop, this massive nebula shaped like a giant ring, a beautiful sight, this giant glowing cloud of gas and dust, all created by powerful supernova explosions.
A supernova remnant. Now that's something I'd love to see up close. What else?
Then there's the galactic halo. It's this huge spherical area around the Milky Way's disk, home to some of the oldest stars in the galaxy, stars that were born when the universe was still young.
Ancient stars. Imagine what they've seen over billions of years. It's mind-boggling.
It really is. We've gone from looking at our neighbor stars all the way out to the edge of the galactic halo. And we've only just started. There's so much more out there.
I can't wait to see what we find next. This has been an incredible journey already, from our closest neighbors to the structure of the Milky Way. I'm hooked on this deep dive.
Me too. And it's about to get even more interesting. Ready to jump into the search for life beyond Earth.
Absolutely. But let's save that for next time. We've covered so much already, I need a minute to let it all sink in.
I agree. It's been a whirlwind tour of the cosmos.
All right, folks, we're going to take a short break here. But we'll be back soon to keep exploring the universe beyond our solar system. So don't go anywhere.
We're back and ready for more cosmic exploration.
I'm ready to dive back in. Last time we were talking about the galactic halo and those ancient stars, the ones that have been around since, like, the beginning of the universe. It's like having a time machine, isn't it? What else can you tell me about these cosmic elders?
You know what's fascinating about these halo stars? They're actually pretty different from the stars we see in the Milky Way's disk, where our sun is.
Different how? Are they like, I don't know, the grandparent stars? Older, smaller, maybe a little redder?
You're on the right track. They are older, formed when the galaxy was much younger, and because of that, they don't have as many heavy elements.
Heavy elements, so like stuff like iron, carbon, oxygen, all the things that make up planets and, well, us.
Exactly. These halo stars formed before those heavier elements were really common in the universe. So they're like a snapshot of what the early universe was made of, like cosmic fossils.
That's so cool.
Yeah.
By studying them, we can learn about how galaxies formed and even how the elements that make up everything we know came to be. It's like a cosmic family tree. But speaking of ancient history, are there any other, unique stars out there with stories to tell?
Oh, definitely. Did you know there are stars out there moving so fast that they're actually escaping the Milky Way? Like they're breaking free from the galaxy's gravity?
Wait, escaping the galaxy, like running away from home? That's crazy. How does that even happen?
These are called runaway stars, and they're thought to get flung out of the galaxy because of some pretty intense gravitational interactions.
Like what? Did they get too close to a black hole or something?
That's one possibility. There's this star, HE 04375439. It's traveling at, get this, 722 kilometers per second. That's fast enough to escape the Milky Way's pull. And scientists think it might have had a close encounter with the supermassive black hole at the center of our galaxy, like millions of years ago. That interaction basically acted like a giant slingshot, flinging it out into space.
Wow, that's a rough breakup. So this star is basically on a solo trip through the universe now.
Yeah, pretty much. A lone traveler on a one-way ticket through the cosmos.
It makes you wonder how many other runaway stars are out there, just cruising through space with their own stories.
Yeah.
It's humbling, thinking about all the things we still don't know about what's out there.
Absolutely. And every new discovery just leads to more questions. That's part of what makes astronomy so exciting. It's not just stars that can exist outside of solar systems. There are also planets that don't orbit any star at all.
Hold on. Planets without stars. How is that even possible? Don't planets need a star's gravity to, form and stay in orbit?
That's what we used to think, but then we discovered these things called rogue planets, or sometimes free-floating planets. They might have formed in a star system and then gotten kicked out, maybe because of other planets, or even a passing star. Or it's possible they formed on their own from collapsing gas and dust without ever being part of a solar system.
So they're like cosmic orphans, just wandering the galaxy alone. That's kind of sad, but also super cool.
I wonder what it would be like on a rogue planet. Just constant darkness and cold.
It would be a very different environment than we're used to, that's for sure. Speaking of strange environments, have you heard about the planet where it rains molten iron?
Molten iron rain. Okay, that is officially the most metal thing I've ever heard. Tell me everything about this planet.
It's called WESP-76b, a gas giant about 390 light-years away. It orbits its star so closely that one side is always blasted with intense heat.
Ah, so it's tidally locked, like some of those other planets we were talking about?
Yeah.
One side always facing the star.
Exactly. And on that day side, temperatures can get over 2,400 degrees Celsius. That's hot enough to vaporize iron. The planet's strong winds then carry that iron vapor over to the cooler night side, where it condenses and falls as molten iron rain.
Wow, that's a rainstorm I would definitely want to avoid. It's like something straight out of a sci-fi movie. It really shows the crazy range of conditions that are out there in the universe. And WESP-76b isn't the only exoplanet with extreme weather. Want to hear about some more?
Absolutely. The weirder the better. Hit me with more crazy exoplanet weather.
Okay, how about a planet where it rains glass sideways?
Glass rain.
Yeah.
Sideways. Okay, now I have to hear about this. Tell me more.
This one's called HD 189733b, and its atmosphere is thought to be full of these tiny silicate particles, the stuff that makes up glass. The winds on this planet can get up to over 7,000 kilometers per hour.
So imagine shards of glass whipping through the air at supersonic speeds. That's insane. What other wild weather is out there?
Well, we've talked about scorching hot planets and frozen ones, but how about a planet that's completely covered in a global ocean hundreds of kilometers deep?
A water world. Now that's something I could get behind. Imagine the kind of life that could exist in an ocean that vast.
It's a fascinating thought. This planet is called GJ 1214b, and scientists think it's a super-Earth with this incredibly deep ocean. But those depths would be under unbelievable pressure. Who knows what might be lurking down there?
That's both exciting and terrifying. It makes you realize how little we know about what's possible out there. What other weird planets are hiding in the universe?
Well, how about a planet made mostly of carbon? Scientists believe that the intense pressure inside this planet, called 55 Cancri E, could have formed massive diamonds.
A diamond planet. Now that's some serious bling. I wonder how much a diamond the size of a planet would be worth.
That's a question for the economists, I think, but it really shows you the amazing diversity of planets out there.
No kidding. We've got molten iron rain, glass storms, water worlds, diamond planets. The universe is so much stranger and more awesome than I ever imagined.
It really is. And with all this talk of diverse planets and extreme environments, it leads us to one of the biggest questions of all. Are we alone in this vast and crazy universe?
The age-old question. It's something humans have been wondering about forever. Where do we stand in the search for life beyond Earth?
Well, I think the first thing to consider is just how massive the universe is. I mean, trillions of stars in our galaxy alone, and billions of galaxies out there. It seems pretty unlikely that we're the only planet where life exists.
That's what I've always thought. The odds just seem way too high against us being totally alone. But we haven't actually found any real proof of alien life yet, have we?
Not yet, but that doesn't mean it's not out there. There are a lot of promising places where scientists are searching for signs of life. One of the most interesting is actually right here in our own solar system, Europa, one of Jupiter's moons.
Europa. But isn't that just a giant ball of ice?
On the surface, yeah. But scientists believe there's a huge, salty ocean hidden under that ice.
A hidden ocean. That sounds like a perfect place for life. Protected from the highness of space by a layer of ice. What an amazing thought. Are there any other places like that in our solar system?
There is. Saturn's moon Enceladus also has a subsurface ocean. And it's even more exciting because we've actually seen plumes of water vapor shooting out from cracks in the ice.
So those plumes are like direct evidence of a hidden ocean. Incredible. Do you think those plumes could contain signs of life? Maybe even tiny microbes or something?
It's definitely possible. Scientists are really eager to send missions to both Europa and Enceladus to study those plumes and look for anything that might suggest life. But it's not just moons that are promising in the search for alien life. We're also looking at exoplanets pretty closely.
Like those potentially habitable ones we talked about earlier, Wolf 1061c and Gliese 370b.
Exactly. Those planets are in the habitable zones of their stars, which means the temperatures are right for liquid water to exist on their surfaces.
Okay, so we've got these potentially habitable moons and planets, but how do we actually look for life on these worlds? We can't just fly over there and take some samples.
Not yet, at least not with our current technology. But we can study the atmospheres of these exoplanets using powerful telescopes.
I see. So we're looking for clues in the air they breathe. What kind of clues are we talking about?
Well, if we find certain gases in an exoplanet's atmosphere, like oxygen, methane, or even more complex molecules, it could mean there's something biological going on.
So it's like we're looking for the chemical fingerprints of life.
That's so cool.
Are there any telescopes powerful enough to do that now?
There are some that are getting close, but the next generation of telescopes will be even more powerful. They'll be able to analyze the atmospheres of distant worlds in way more detail. It's a very exciting time for the search for life beyond Earth.
I can't wait to see what we find. It feels like we're on the edge of some major breakthroughs. But even if we don't find intelligent life, wouldn't finding any kind of life, even just microbes, be a huge discovery?
Oh, absolutely. It would change everything. It would prove that life isn't unique to Earth and that it can arise in all sorts of different forms and environments.
It would make us rethink our place in the universe and how we understand life itself.
Imagine the implications for science, philosophy, religion, everything. It would be a total paradigm shift for humanity.
It's both thrilling and a little scary to think about.
I agree. But in the end, I think it would be a good thing. It would show us that we're not alone in this vast universe and that life is more common and more diverse than we ever thought possible.
It would open up a whole new chapter in human history and our exploration of the cosmos. But speaking of exploring, we've covered so much ground in this episode. Where do we even go from here?
Well, there's still so much more to discover. We could delve into the mysteries of black holes, explore the possibility of parallel universes, or even discuss the ultimate fate of the universe.
Wow, those are some heavy topics. But I guess that's what this podcast is all about, diving deep into the big questions and mysteries of the universe.
Exactly. And I can't wait to continue this journey with you.
We're back for the final part of our cosmic journey. Exploring the universe beyond our solar system.
Yeah, it's been quite the adventure, hasn't it? From nearby stars to runaway planets, hidden oceans, and even a planet with molten iron rain.
I know. My mind is still blown from all the amazing stuff we've talked about. But we left off last time with a pretty big cliffhanger. The search for extraterrestrial life.
Right. It's something that everyone seems to be curious about.
For sure. So where do we go from here? What are the most promising ways to search for life beyond Earth. I mean, we talked about those icy moons, Europa and Enceladus, and those potentially habitable exoplanets. But what are scientists actually doing to try and find proof?
Well, a big part of it is looking for what we call biosignatures.
Okay, biosignatures, what are those?
Basically, they're any signs that could mean life exists or existed in the past. It could be like chemicals in a planet's atmosphere, geological stuff that suggests there was biological activity, or even signals that seem like they're artificial.
So, like, clues that point to life, even if we don't actually see the life itself. What are some examples of these biosignatures?
Well, in terms of atmospheres, one of the big ones is oxygen.
You mean like the stuff we breathe?
Exactly. On Earth, most of the oxygen in our atmosphere comes from photosynthesis, from plants and other organisms. So if we find a lot of oxygen in the atmosphere of an exoplanet, it could be a sign that something's producing it biologically.
That makes sense. What other atmospheric clues are there?
Methane's another one. It can be made by biological stuff, but also by geological processes. So finding it along with other gases like oxygen or carbon dioxide could be a stronger sign of life. And then there are even more complex organic molecules like amino acids. Those are the building blocks of proteins. Finding those in an exoplanet's atmosphere would be a really big deal.
So it's kind of like a cosmic game of Clue, but instead of a candlestick in the library, we're looking for methane and oxygen on a distant planet.
Uh-huh. That's a great analogy. And just like in Clue, the clues can be a bit tricky to understand sometimes. That's why we have to be really careful and consider all the possible explanations for what we see and not jump to conclusions too quickly.
Right, we don't want to get excited about something that's not really there. So are there any biosignatures that would be, like, more certain? Like a smoking gun for life?
Well, finding something like complex organic molecules that are definitely the product of biological processes, that would be huge. Or imagine finding structures or patterns on a planet's surface that could only have been created by intelligent life.
Like alien cities or giant crop circles. Now that would be a discovery.
Absolutely. But even if we don't find anything that dramatic, any sign of life beyond Earth would be a monumental discovery and would completely change how we understand the universe.
It's amazing to think that we might be this close to such a huge discovery. It makes you wonder, what would happen to humanity if we did find undeniable proof of alien life?
I think it'd be one of the biggest things to ever happen in human history. We'd have to rethink our place in the cosmos, our ideas about what life is, and maybe even our own beliefs.
It's almost too much to take in. Do you think it would be a good thing or a bad thing for humanity?
Hard to say for sure. It would be a huge change, and there would probably be a lot of fear and confusion at first. But in the end, I think it would be good. It would show that we're not alone, that life is more common and more diverse than we ever thought.
And it would open up so many new possibilities for science, philosophy, everything. It would be a whole new chapter in the human story.
Exactly. And who knows what we might learn from other life forms? What kind of knowledge, technologies, or perspectives might they have to share with us?
It's mind-blowing to think about. But as much as I'd love to keep talking about alien civilizations and all that, it looks like we've reached the end of our deep dive.
It has been an incredible journey, for sure. We've explored our galactic neighborhood, learned about all these bizarre planets, and thought about the big mysteries of the Milky Way. And really, we've just scratched the surface.
Yeah, that's right. The universe is vast and full of wonders, and there's still so much left to discover.
So keep looking up at the stars, keep asking questions, and never stop exploring.
And if you want more cosmic adventures, be sure to follow Cosmos in a Pod and subscribe to our YouTube channel. Until next time, keep wondering and keep exploring.